Hey guys, welcome back to my channel. My name is Anuj and you're watching Analytical Anuj, and this is going to be a different video as this is going to be a completely raw, uncut video about machine learning project on UPI based product systems. If you're watching this from abroad or outside India, UPI basically is a payment technology in India wherein you can just scan a QR code and make a payment from one bank account to another bank account. So this is a very common technology in India and we have been using it for almost a decade now. And if you're familiar with it, that's great. Otherwise, you can learn something new. And I'm going to walk you through every step from data analysis to building the machine learning models going forward. So before we dive in, I just want to let you know that this is not going to be absolutely from the scratch. So I need you to install Python, I need you to install Anaconda Navigator, and I need you to have Jupyter notebooks installed before you can start working side by side if you want to work side by side, which I recommend is the best way to learn. So if you have 1 hour, please watch this in one sitting, or you can pause as you want. You can definitely dive in whenever you have time. So have those tools installed. I have already have made other videos on my channel on how to install Python, how to install Anaconda Navigator, how to install Jupyter Notebook. So please go through them. Once you are ready, you can definitely start working side by side. And this video covers a lot of very frequently asked interview questions and hands-on techniques. So it's a great idea to either watch till the end or try this side by side with your own project. That being said, let's get straight into it. For some reason here, my audio was not getting recorded, so I made like 1 hour worth of video. I was doing live, but for some reason the audio was not getting captured. So here I am recording it once again. Hopefully now you can hear me in the audio part. Okay. I did all of this in the last 1 hour. Yet here I am. No worries. So we'll get to it. Let me quickly start with the agenda of the project, okay? So in this video, we will talk about how do we import the data to Pythons, or you can say pandas library. We will see what is the top data or top 5 rows of data, how the data looks like, the basic description of the data. We'll talk about the data preparation part, wherein I will tell you how do we remove duplicate values, how do we find the duplicate values, and then we'll drop some columns which are not so important for the data analysis part. We'll see then what are the missing values in the data set, and how do we work with the missing values, the different ways we can use to overcome this challenge. Then we'll check what are the different data types available in my data. We'll start with the descriptive analysis of the numbers, and then we'll create a new columns for my data with as respect to the analysis, and then I'll do some data transformation bit as well, and I will finally show you what is the data distribution like in my project. So let's get into it. And if you have not installed pandas or Python, any of it on already, so don't worry, I will tell you, and you can watch the other videos on my channel as well, and you can subscribe for more videos like this, and hopefully we can get to go. All right, so as I did everything here, I'm just going to start a new notebook. Okay, so in this process, we will start with importing the data to our notebook. So this is VS Code. I'm working with Visual Studio Code, but you can also work with Jupyter notebooks. So let's see. So I'll show you both the ways, okay? So this is how the Jupyter notebook looks like. And once it is ready, it will look somewhat like this. So you can start creating by going to new and clicking on new notebook, and you will have this notebook available. And I can double click on it. I have this notebook handy. Okay. Anaconda assistant, let it be. I don't need it. Okay, so we have this data available now. This is the Jupyter notebook, which is your conventional Jupyter notebook. And I am more comfortable using Visual Studio Code. So if you want me to make a video about how do you install and set up Visual Studio Code, let me know down in the comment section and let's get on to it. I'm going to use Visual Studio. So on Visual Studio, if you already have installed the right extensions, I'll show you the extensions that I have installed. I have installed Python, IntelliCode, and the relevant Jupyter Notebook extensions I've used is Jupyter Notebook, Jupyter Cell Tags, Jupyter Key Map, Jupyter Slideshow, and I would say, yeah, these are the pretty much. Let it be. It's okay. So yeah, these are the list of extensions that you can use, and now let's get on to it. So this is our Visual Studio interface, and that's how it looks. I hope you can see what I'm trying to share on the screen. Okay, I'm just going to zoom this, making myself a little smaller for you, your convenience. Let me know how this looks. All right, brilliant. So I hope the camera angle is also okay. Otherwise, I can fix it like this. Perfect. So in this video, we'll talk about the, 1 second, I'll just take the agenda from here. I'm hoping that you already know what we are in for, and you already have some understanding of Jupyter notebooks and how these things work. If you're absolutely new or absolutely a beginner who just has a curiosity to understand how these things basically look like, I do appreciate that. But I will not be covering the very basics of everything, but I'll try to explain everything in case you are a non-tech person trying to learn and just see how this basically goes. Nevertheless, now let's get started. So the first step that we are going to do is data, or importing libraries. So in Jupyter Notebook, we have two different types of cells. We have code cell and then we have markdown cell. So code cell is where you want to write your code. Markdown cell is basically where you want to write any of your comments or doc strings basically. So as you can see, I'm just noting down my notes, and 1 second, let me just adjust the light in case it's not very good. I hope that this is a little better. So when it comes to libraries, you can install with install pandas. Let's see if it works. Is it a markdown? Okay, if it's a markdown, I can change it. I can change it to Y. Now we'll try and fix it. Okay. So when I run this, it says select your Python interpreter. So I'm saying Python 3.12.5 at the top. I'll zoom in a bit to make it easier for you. I hope you can literally see this now a lot better. So install pandas. As you can see, there's a red warning. It says statements must be separated by new lines or semicolons, pylons. So I have this bulb stating that, okay, we have to replace this with percentage pip install. So in case you are going to install pandas for the very first time, you have to install the libraries first. And in case you want to install it, you can use these statements, which is percentage pip. Okay. Uh, I think it's Python installer or Python installer package or something like that. So you can just use percentage pip space install space the name of the library, which can be pandas, matplotlib, seaborn, or any libraries we are going to use. Okay, because I already have it installed, I'm just going to say import pandas as pd. This is one way to do it. Then we are also going to import numpy as np. Okay, and I'm going to use variety of library. Okay, seaborn as sns, import matplotlib dot pyplot as px. So this is one way of doing it, that you can import the individual libraries. But one other way that you can use is just import pyforest. Pyforest is one library that will have all the important libraries which you need for your data analysis. And if something is not included by default, you can always import it separately. So I always prefer using pyforest, but yes, this is one way you can also use. I'll just change it. Okay, so yeah, I hope this helps. Just comment it out. So I have imported pyforest. So now we'll start with the first step, okay? Which is your data collection. So I'm going to import the data to Jupyter Notebook. Okay. So we're going to use pandas for data manipulation. To work with data manipulation, to work with data frames, we use pandas. So df is going to be my data frame, pd.read underscore CSV. I can give the path of the data set. So let me see where is my file located. Let me just check here. Where's my file? Where's my file? Where's my file? Where's my file? Not too sure where is it located. Sorry for this, guys. I'm gonna have to just check. Okay. Mhm. Okay, I found it. It's in documents. Control plus I. I've got this available here. So now that I have the path, what I can do is I can just paste the path and say UPI latest dataset. Run it. Error. File not found. No such directory exists. Read underscore CSV dot CSV. Okay. Seems like it exists now. Okay. So the now the data frame is being imported. So read CSV file. So the idea is that we are using pandas to read the data set, and once it is imported, it will use the default encoding as UTF-8 if I'm not wrong. So by default, it always uses this particular encoding, but sometimes this encoding might not work. So you might want to use Latin 1 or some other encoding techniques. Okay, these are called encoding techniques. So the data is always stored with some sort of encoding, and when you're trying to read the data, sometimes it might work, sometimes it might not work. So these are some things to watch out. Let's see if my data is imported. So top 5 rows of data. Let's see the top 5 rows of the data. Okay. So df.head. df.head is a function that shows you the top 5 rows of data by default. So this is how it looks. So if I show you my data, first let me give you an overview of what data I'm working with. So I'm just working with the data for Unified Payment Interface. If you're watching from outside India, just to give you the heads up, it's a financial project that I'm working on. In this project, we are trying to figure out what all data is fraud uh, in transactions. So these are real-time transactions. And in India, we have Unified Payment Interface. So this technology allows you to basically scan any QR code and directly make a payment from your bank account to their bank account. So this is quite common in India now. And if it is not being used in your country, so you can check out this website, which I'm just going to show you. Yeah, I have this open. So you can just search for npci.org.in and it will tell you about Unified Payment Interface, the product overview and how this works. So you can just get into the technical jargons of it. So we can scan any QR code and make a payment directly from our bank account into their bank account. So this is the overview of the project. So I have captured 2 years worth of data, 2023, 2024 for fraudulent and non-fraudulent transactions. And I'm just walking you through the steps of this data analysis part. So as you can see, my data is imported in the first step. Now the step 2 is the top 5 rows of the data. So what all data, the columns we have is transaction ID, date, time, merchant ID, customer ID, device ID. Then we have transaction type. Let's take it to the right. Payment gateway, transaction ID and all that. So we can see the different features we have available. Okay. And at the end, we have the target variable, which is the fraud. So 0 means the transaction is not fraud, whereas 1 means the transaction is fraud. Okay. So the df.head function by default will show you the top 5 rows of data, but you can always define the number of rows you look for. And therefore, you can specifically define if you want just 2 rows or 1 row and 3 rows and so on. So this is how it looks. Let's move on. One more pandas feature you can use is df.columns. So you can see that I'm not using the parentheses here. So this is how it works. It will generate a series separated by comma, showing me that these are all the columns I have in my data set. Just at a glance, you can see them. And next, df.info. So df.info, this is one more function available in the pandas library, and it tells you what all different data types are available. So as you can see, I've got on the left the columns available, which can be your transaction type, date, time, merchant ID, customer ID, device ID, and so on and so forth. On the right, you can see it says non-null values. So 50,000 non-null values, data type is object, numbers is integers, and floats. Okay, so I can see the data available here and the overall description of what is the data types, how many variables I have, how many numbers I have, how many categories I have, and so on. So I can use it with the help of data.info. Okay, so you can see I recommend you to do this side by side in case you can. Okay, I'll share the data set in case you want. Data description. So now that we have seen this, okay, let me see if I'm missing something because I already did this just now, but the audio was not recorded. Data importing, okay, okay, I'm not shared maybe. So the link, to understand UPI, there we go. So let me use this here. One second now. Okay, it was here all this time. I was just missing out. df.info, we have already seen it. Then we'll move on to descriptive analysis. We can use this df.describe feature that will tell us the numerical columns in our data set. So for example, the transaction frequency, amount deviation, days is last transaction, amount, and fraud. So these are the numerical columns, and it is trying to show us the count of rows for each and every variable here. The average value, which is your mean, standard deviation, minimum value, first quartile, second quartile, third quartile, which is your 25%, 50%, 75%, minimum value, and maximum value. So this is your description of the data. And if I just want to read it better, I would say dot T, which means I can do a transpose. And now this is a lot more readable, right? So I can have all the columns on the left and I can have the values on the right. So this is your descriptive analysis. I hope you got the idea. Moving on. So I hope I'm not missing out on something. Just give me 1 second, okay? I'm just going to refer through my notes so that I can show you everything in a very structured way. I'm not. Okay. I don't want to miss out on anything while I'm explaining things to you. So we have seen df.head, we have seen the information part, the data types, we have seen the descriptive part. Now we can see data.head. Dot head, we have already seen it, right? Okay. We have already seen. Moving on to data preparation. Data preparation, we are going to talk about the duplicate values. Then we're going to talk about the missing values. Then we're going to talk about unique values. Then we're going to talk about removing or dropping the unique values. So these are the things that now we are going to do in data preparation part. So let's get on with the first one, which is your duplicate values in the data set. To find the duplicate values in the data set, you can use the function df.duplicated. Okay, so this is how it looks. So df.duplicated. If I just do this, it will return the Boolean output. The Boolean output, as you can see, the data type says bool at the end. I'm just going to highlight this for you. It means it is showing you that the data is either true or false when it comes to duplicate value. So for every row, it is trying to check and see and tell you whether this was a duplicate or not. But this is not so readable. So you can use dot sum. So I want to check the sum of all the duplicate values. What is this? It is supposed to. Okay. Perfect. 0. So now this is basically trying to tell me there are no duplicate values in the data set. Okay, so in my data set, luckily there is no duplicate values. Let's suppose I had, so I could just use df.drop duplicates, as you can see, this method, and you can drop duplicates here. Okay, so this is one thing that you can do. But because in my case there are no duplicate values, so I'm not going to be dealing with duplicate values. Moving on to the next part. Next thing we are going to talk about is missing values. So when you talk about the missing values here, we can use the isNull function. Apologies for the noise. So when we talk about the missing values, we have the isNull function. IsNull function talks about checking whether the value is missing or not missing. So we can have false or true. Okay. I apologize for the noise if you're getting any. So as you can see in this entire data frame, I can see what data is missing. So if it is missing, it will say true. Otherwise, it will say false. So it's not very readable. Okay. I will say some to make it more readable. So now as you can see in my data frame, I have the columns on the left and the missing values on the right. So we can see that I have very less missing values or probably zero missing values in my entire data set. So that's one way. But how to deal with missing values? I will still tell you how do you deal with missing values in case you encounter missing values. Okay. Change it to M. So there are some ways to deal with the missing values. Number one can be drop the missing values. Okay. So only if the data or missing values is very less in proportion. So this is only recommended when your missing values is only, let's suppose, 2 or 3% or 4% of data, because the more data that you just delete, right, we are losing out on some other information as well, which might be a key to our data analysis. So it's not recommended to just drop whatever is missing. We have to check what is the percentage of the drop or missing values. If the comparative percentage is very less, so it's okay to drop the missing values. Otherwise, we have to use amputation. When it comes to amputation, we have to fill back the missing values. Okay, so we can use forward fill. Forward fill is a technique basically that allows us to take what's the next value and we can use that to fill the missing value. This is one of the techniques which are being used. Then we have something called backward fill. Backward fill is just again taking the previous value and just filling it. So this is one way to do it. And apart from this, we can use linear regression. So we could use the regression techniques to identify basis on the uh, of normal values, what should be the most appropriate value that we can use here. We could also use the mean value to replace the missing value, but this is not recommended as mean is sensitive to outliers. If your data is not normally distributed or it contains outliers, if you're replacing your missing values with the mean values, it means that the resultant data will not be accurate. The resultant data will not be accurate in case your data does not follow normal distribution and your data contains outliers, because mean value is sensitive to outliers. So that is why if you're replacing your missing values with your mean value, your data has to be normally distributed and you have to ensure that there are no outliers in the data. What is a more robust way of handling the missing values? You always should be using the median value. Median value should be used to replace the missing value as it is robust and is not sensitive to outliers. Data distribution does not matter here. So data distribution does not matter. So we have to always realize what is the data distribution if you are trying to use these any of these techniques, right? So when it comes to your normal distribution, your mean for normal distribution, your mean equals to median equals to mode. Okay, so even for normal distribution, you can use median, because it's anyways equals to mean, which is a standard practice, right? But even if your data is not normally distributed, you can always use median because it is not sensitive to outliers and it's not relying on normal distribution in which ways. So you can use any of these techniques to handle missing values in case you encounter any missing values. For my case, there was no missing values, and that's why just give me 1 second. Okay, in my case it was not required, so I was not working on it. Just 1 second, guys. All right, guys, so now we'll talk about the shape of the data set. I hope you understood the concept of amputation from the missing values. Now we'll talk about the shape of the data set. To check the shape of the data set, you can simply use shape method. df is not defined, and all the values upper. Should work now. So if you want to check the shape of your data set, you can see it says the data contains 50,000 rows, 20 columns here. Okay, so this is one way to check how many or what's the volume of the data that you're working with. In my case, I've handled the missing values, and now we are going to move towards the unique values. Unique values in the data set. So you can use df.nUnique, and it will show you what is a unique value in your data set. So on the left hand side, you can see the columns, which is column names, and on the right hand side you can see the unique values in those data, right? So in the previous command, we have seen that there are 50,000 rows of data. In the 50,000 rows of data, if I have 50,000 unique values in transaction ID, merchant ID, customer ID, device ID, and IP address, we need to understand that as a data analyst, you want to try and understand if there are any patterns in your data. Unique values do not contribute towards the data analysis, and that's why there is no point keeping this particular features in your data analysis. So the first thing we want to do is drop these unique values. Drop the unique from the data. So we want to drop the unique value. So now we'll talk about how do we use the drop function. So df.drop, this is one way, and you can just mention the name of the column that you want to drop. So let's suppose I want to say, I don't want to be making any mistakes. So I can use a df.columns function to get the name of the column, and I can just, 1 second. I hope I can, maybe I can put myself like this. Will this be too big? I can just go back here. Can I not increase the size? Anyways, so in draw function, we can mention the name of the column. So let's suppose uh, 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 so if I do df.drop transaction ID, you just have to mention the column name and it will drop that particular column. And if I do this, let's see what happens. It says access is not defined or access not found. The reason this is happening is because by default, it always tries to check it in the rows, but because the transaction ID is not available in rows, it's available in columns. So you have to mention access equals to 1. Access 1 equals to 1 means it's basically a column that's available in. I'll go back to the right, and now you can see the transaction ID column has been removed from the very top. Earlier we had the transaction ID at the very first column. Now it's not available, but let me show you something which you might be missing. So whenever you use the drop function, it does not modify. The drop function does not modify the original data set. What do I mean by this? For example, if I just do df.head and I get the two data, right? So you can see that this column is back. Transaction ID column is now back but I just removed it, right? I had just removed this in the previous command and it was removed already. But how come this is back? It is back because it is not modifying my original data frame. My original data frame is basically df. So I have two ways to fix this. Number one, if you want to fix or permanent or save your changes, so you can just say df equals to df.drop. So in my original data set, I want to save these changes. And now if I run this, just see what happens. I have removed the transaction ID and I've saved the changes to my original data set. Now if I run this command once again, you should see that this column will be removed. And if you want to see this, let's do it. Now, as you can see, the transaction ID column has been removed permanently. So this is one way to remove the columns from your tables. The another way is just, now as you can see, I had multiple columns with the unique values. So I don't want to be removing them one by one. I want to remove them in just one go. So I'll show you the second way. So first is df.drop, and you can define the columns. So once again, I don't want to be making a mistake. So I can do df.columns, and now I should have all the names available. So I want to use the merchant ID, which had the unique values. I can mention merchant ID, comma, and customer ID and device ID also. Yeah, I can just mention this. Okay. Customer ID, device ID has been mentioned. Then I had IP address. IP address is also unique values. Once I'm done with this, I can do is in place equals to true. So when I do in place equals to true, I do not have to do df equals to df.drop. I'm basically telling my system that I want to save these changes. These changes are supposed to be permanent. So now when I do this, let's see what happens. The merchant ID, customer ID, device ID address is not found in the access. How could I do this again? So I can say access equals to 1, in place equals to true. So I've defined that these are basically the columns I want to remove, not the rows. And then it checked it in the columns and it saved it into the original data frame. So now once again, if I do df.head, I should not be able to find these respective columns. So as you can see, the transaction ID, merchant ID, customer ID, payment, and IP address, these columns have now been removed permanently. So your data preparation part is over. So now we'll move on to the next part of the analysis, which is going to be your just to do a quick recap. In the data preparation part, we have checked the shape of the data, which is df.shape. Then we have checked for the duplicate values, which is df.duplicated.sum. And then we have checked for missing values, which is df.isnull function dot sum. That gives us the missing values. We have also checked the unique values with the n unique features. So n unique function we have used at the top, this one. It tells us the unique values for every single column. And then we have used the drop function to drop the unique values from the data. So all the 50,000 rows which are unique, we do not need this for our analysis. We have removed it now. And once that part has been done, we'll move on to the next part of the analysis, which is going to be data cleaning and data engineering. Okay. So when it comes to data cleaning, we want to ensure that the data is consistent in the required format and the data is does not have any missing values, duplicated values, and the formatting is correct and it's consistent across and the quality is good. And then we'll talk about the feature engineering bit. So in the feature engineering section, we'll talk about what are the most important features which I want to include in my data analysis. And feature engineering is very, very important. So most of the data analysts, when they work on any project, the 70% of the time is basically spent on data cleaning itself. If you're a data scientist, then you will basically have the data which is already cleaned and you just have to work on the models part, but you might still be doing a bit of data cleaning here and there just to get started. As a data analyst, the data cleaning part is very important. So you should be very thorough understanding what is the source of data, how to combine different data sets together, how do we clean the data set, how do we remove unwanted things, how do we make the data consistent, how do we check the validation, and all these things. So we'll talk about these things here. Okay, so I want to show you something. There is one more way to access a column. So for example, if I want to access one column, I can use square brackets and I can define date, for example. And there we go. We can see the date column is accessed. There is one more way to access a column, which is df.date. If I just do this, as you can see, both of them are working fine. So I can use this approach, or I can use this dot function to access my dates or any column values. It works. The problem with this one is that if I want to access any other column as well, let's suppose I want to say amount as well, it will throw the error. It says series object has no attribute called amount. So this approach fails when you have multiple columns and you want to work with. So if you want to access multiple columns, this approach fails. So you have to rely on this approach. I'll show you how this works. So let's suppose I want to access some other column. Let's suppose I want to access the amount column as well. So this is also going to throw an error. I'm going to show you how. This is not working. Okay. It says the key error, date and amount is not working. The above exception was the direct cause of the following exceptions. And there we go. So in the date and amount part, it's not working. So whenever you want to access multiple columns, what you want to do is rather than using single square brackets, you want to use multi-square brackets. So I can use double at the start, double at the end, and now I can just mention as a list within the list. Now if I run this, it should work. It says amount is not in the index. So maybe I'm making a mistake here. So what I can do, I can just check the columns here just to see what amount I have. So amount seems to be available. Should not be a challenge. So the spelling was not right. Now I am able to pick up two particular columns, right? So this is how we can define the number of columns you want in a data frame when you want to work with. This is one approach, so approach, and then we have the square function approach. So this is how you access a data frame first. Now moving on to the next part, I want to show you something. So if I use the .head function, I can see that I have got date, time, and all these functions available. Now I want to show you something. First of all, when you want to analyze, you might want to create some new columns that you want to work with. In this case, I have got the date available. So as you can see, the date has 23rd of October 2023. Then I have 19th of January 2024. Initially, at the beginning of the video, I told you that there are 2 years worth of data I have, which is 2023 and 2024, which means I've got two particular years of data available for my analysis, and I want to use it for my analysis. So what I'm going to do now is I'm going to take the date column and I want to extract the year, and I'm going to create a new column for year, which is going to be 2023, and then one more column for 2024, one column for year basically, and then I will do year by analysis. Okay, so how many transactions of fraud in 2023? How many transactions were fraud in 2024? And I will see a comparison of is it like a year by year approach, right? Or in which particular year we had a more amount of fraud transactions. So we can see like that. One more thing we can see is that we will extract the number of months. So we have the month available here. So we'll see if there is any specific correlation between the months and the fraudulent transactions. So for example, in December or in October, we tend to have people doing shopping online and all these things. So maybe the chances of fraud might increase. So we'll validate all that information using the month column. So everything will give you some information. As a data analyst, you need to understand what features can be important to you and what columns can give you some variety of insights. So I can see that I have got one date column, which includes my date, month, and year. I will extract the year and I will extract the month, and then I will do the analysis by month. I will do the analysis by year, and this gives me two additional columns to work with. Let's see how to get this done. So one thing that I'm going to do is importing date and time module in Python. So you can see import date, the date and time, importing the date and time as dt. Okay, what it does, I'll show you. Let's suppose I have got this date function, right? Okay, dt dot year. df year. Give me 1 second, I'll explain. So maybe I want to create a new column called df of year. In the year column, I want to use the date function or the date column, and I want to use the date and time module to basically extract the year of it. Okay, and I'll show you. Use a dt accessor with the date time like values. Okay, so let me just check. Okay, so maybe what's happening here is when I'm using this, it says can only use .dt accessor with the date time like values. Okay, so we first of all have to help the system understand the format of the data. So date dot pd dot to underscore date time. Okay. So I'm going to use the date column, and I would say use pd dot date or to date time. I'm using the pandas module for date and time, and I want to say use the date column, comma, format would be equals to percentage d slash percentage m percentage y. If I run this, okay, it says invalid syntax, percentage d. Okay, what's my date and time like? P dot to date and time, data this. Okay, format equals to one this. Okay, so it needs to be separated here. D, M, and Y, hopefully. And if I just take my cursor here, let me see. No quick fixes, was not closed. Was not closed. 1 second, date and time. The format is this. Okay. So date and time, leave date. Seems to be correct. The date column, pd.to underscore date time, near date. Formatting is this. It should be running. Should not be a challenge. Have I imported this as DT? Hmm, maybe there's an issue. Let me just see. But there should not be a challenge. Sorry guys, I just encountered an error. Hopefully I will be able to fix it here. Let me see. I imported a data time as DT. Was it PD or DT? Format D slash Y. Okay, I got it. Invalid syntax. It's supposed to be in quotations. It's a string. It's an object. Percentage D forward slash percentage M forward slash percentage Y. Okay, PD. What is the challenge? PD is not defined by pylons. What? I've been using it. It's supposed to work. I've been using it, right? PT dot date and time. What was the challenge? PD PD is not defined. Okay, understood. The challenge that I'm facing right now is because I have included PyForest, so I can access all the functions, but it says PD is not defined. Okay, let me just try and fix all the warnings. I'm just getting this warning, so import pandas. All that is working for me, but maybe this is why I was getting these errors. So now module is okay. So I was just getting a warning. So you don't have to worry about warnings basically, but sometimes if you are getting warnings, you might want to ignore the warnings or you can work like this. So let's see. So we have imported the date and time module as DT, and then we have taken the date column, use the pandas PD module dot to date time. This is the module that we're using available in pandas to convert the date format to df.date comma format would be within quotes. So because it's a category, so you have to put it in quotes, percentage D, because it's supposed to be date, then forward slash, then month, then forward slash, then year. So this is done. And now what I want to do is I want to create an year column. So I want to create an year column, which should be equals to df.date. Sorry. I want to take the date column and I want to say So I want to take the date function and I want to apply or extract. I want to use the date and time module first. And then from the date and time, I want to take the year. Okay. So let me just explain this. So basically I'm extracting the year from the date and time module from the date column. I hope this explains it better. Let's see what happens. It says date, key error is date. Maybe the column name is not right. It should work. So what I've done here is basically I've created a new column. So this is where I'm creating a new column. Creating a new column, which is your year column, with the help of a date time module available in pandas or Python or no, come on, man. Date time. Yeah, pretty much. Apply it to date column. Okay, so basically, I hope you got the idea. So what I'm doing here is I'm taking the date column dot my module, which is your date and time module, and then I'm applying the function year to extract the year from this date column using the date time module. Function is year. And now when I'm getting the year out of the state, I want to put it somewhere, right? So I created a new column called year, Y in caps, which will create which will basically hold all the years, right? So 2023 and 2024 will be created here. So when I run this as it is run, so I'll just show you. Now I should have one more column, year at the very end. So as you can see, the year is now captured as 2023, 2024, and so on. So one column has been created. So what I will do now is create a month column with the month of transaction. Okay, so now we are going to use the same feature and we are going to use, let's suppose I want to create df of month. I want to use date column, use the date and time module, and I want to take month. Okay, and I want to save it in the month column. So I will run it, and I would say extracting the month from date column using date time module available in Python. And I will just save it. So now I have the month column, and now if I just go back and you know what, I'll just drag this command here. So I don't have to write it away always, right? Now if I run it, initially, as you might have seen, I had the year column, but now I have the month column as well. So as you can see, I've got the months available. And let me just see for the month column. Now I want to see what are the available values. So if I just put it like this, so you can see in the month column, I have values ranging from 10, 5, 1, and so on. So it showed me 50,000 values. I don't want to see 50,000 values. I only want to see the unique values. So how do we get the unique values? Unique function. So now it is showing me the unique values which range from 10, 5, 1, 9, 6, blah, blah, blah. But I've got some values, but they're not ordered. So not readable, right? So now what I will do is I'll sort this series or array or list, whatever you want to call it. So I would say df month dot sort. Do I have something? Sort values. And I want to sort them in the ascending order. Is that sufficient? I want to sort them in the ascending order, but if I do this, I'm assuming if I'm sorting the month column, I will be sorting the entire 50,000 rows. And I don't want all the 50,000 rows. I just want the unique values, but I'll show you still anyway. If I just run this one, so you can see I'm still getting all the 50,000 rows of data. It's just in the ascending order, but it's still 50,000 rows. I don't want 50,000 rows. I just want the unique values. So now if I run this, you can see I have the month column values 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I've got months ranging from 1 to 10. This is one task completed. Now, Still, it's not more readable, right? So what I can do is I want to replace the months to months column to have a format MMM as compared to numbers 1 to 12. So what I want to do is I want to create a dictionary. In a dictionary, basically you have key value pairs. So I could have like 1, that means, let's suppose I would say January, and I can say 2 means February, and 3 means March. So you got the drill, right? So I will not be writing it down once again because I already have written the entire code myself and it took me a lot of time. So let me just copy and paste this that I've already written in my previous code. Come on, man, seriously. Okay, so now as you can see, I've got these values ranging from 1, which means Feb, until 12, that means December, separated by comma. And because these are string values, they're always in quotes. Single quotes or double quotes does not matter, but this is a dictionary I've created. So I can literally say creating a dictionary with key value pairs, the number of months, and their respective names. So now that I've created a dictionary, defining the values in my dictionary. Now that I've done this one, what I want to do is I want to take my months column, and if I say unique values, I was getting the unique values like this. Can I use the ascending order? No, not here. Can I use dot ascending order? Nah. I have to use the sort values function. Under sort values, I would say ascending equals to true, unique values, and now I'm getting all these values, right? So I have this month column that has range values ranging from 1 to 12, and what I want to do is I want to say take the month column, and now what you want to do is I want to use the map function. Now map function is very important. So date the month function, and I want to say map my dictionary which I've made with the help of months. I'll show you what I'm trying to say. I am saying map the dictionary to the month column. Okay. So now what I've done is in this section of the snippet of the code, basically I have mapped all my months, which is your dictionary, right? So it's checking the number, the corresponding number in my month column, and then replacing it with the help of the values available in my dictionary. But this is not going to save it. Let me show you what do I mean. So I've done this part and it's basically showing me that it is replacing the value with the respective month. But if I just do df.month, it still has just numbers. But we had just replaced it, right? We just applied the function, but it's still not reflecting. So for example, what I'm trying to say, if I again show you everything, I again go to the last section, my data is still in numbers. The reason it has not happened is because it is not modifying, it has not modified my original data set. This is a trick question you need to be aware of. Whenever you're modifying column, you have to say df of month column. I don't want to be changing my entire data set. I only want to change my month column. So whatever changes are applied to this month column, these are now replaced in the original month column in my data set. Once I do this, you just see the magic happening. Currently the months are numbers. So if I apply these changes, which are now done, we can still see numbers, right? Let me run the code again. The moment I run this, you can see that now the numbers are replaced with the months, respective months in the correct format. So now let's see what all columns are available. I still have, okay. So I have these columns available. You might have noticed we have extracted the year from the date column. We extracted the month from the date column. but we still have the date column available. So basically I have got one redundant column that I don't need. So what I can do is drop the date column. I don't want the date column anymore because I've already taken the year and month from this column. So this is an extra column. So what I can do is df.drop. Hope you got it now. And I can just define my date column and say access equals to 1, in place equals to true. This should work. And now if I run this again, this date column should be removed. Now, as you can see, the date column has been removed. And for the simplicity, I'm going to remove the time also. I don't think I need time also. It's going to be a lot more detailed and I don't want to invest that much time already. So I'll just copy the exact same code, but now rather than for the date part, I'll also remove the time part. What? Okay. Date is not found in the access because date is already removed. So now the time column has been removed also. So you can see I'm not sure what's the length of this video. So it's almost 55 minutes, but I hope that you are getting the value out of it. So in this video, what we have done so far is we have learned how to import these libraries. We have taken the 5 rows of data. We have checked the duplicate values, removed and dropped the unique values. We have checked the missing values of the data. We have learned how do we work with the missing values. And these are the very important questions that comes into the interviews. So handling the missing values, how do you handle the missing values? How do you work on the outlier part and everything? So we'll talk about those sections. Then we have seen how do we check the data types. We have seen the descriptive analysis on the numerical columns. We have created 2 columns with the help of the date and time module for the date section. So we created a year and month column and we have mapped the months dictionary. So I created a dictionary to convert the numbers into the respective format and then the target value distribution. So one more question and then we will be wrapping up this video and I will show you the next one, the next steps. So hopefully you'll get a lot of value from this project. So watch this video till the end. This is going to be very helpful. So now I have dropped the columns and I want to see my data distribution. I have the fraud column and I want to see the distribution. So what I want is the value counts. So I've got 50,000 rows of data, out of which 49,226 transactions are non-fraud. 774 transactions are fraud. It's a little difficult to put this into perspective, but I'll make this easier for you. I'll just say normalize equals to true and multiply it by, or just I'll show you step by step. So now you can see almost 98% of the data is non-fraud and only 0 point or hardly 1%. So I'll just multiply this by 100 and now you can see 1.5% of the data is basically fraud and 98.45% data is non-fraud. So this is the distribution. And if I want to draw a visual using seaborn library for data visualization, what I can do, sns.countplot, it is giving me warning. It says SNS is not defined. This is not defined because I have not defined it in my libraries that I'm going to use SNS. So what I can do is I can say import seaborn as SNS. Now I should not be getting this warning. So if I go down, now there is no warning. So there is no yellow ribbon coming at the bottom, right? So sns.countplot. I want to draw the count plot, but I have to define what is the data source. Data source is my df, which is data frame, comma. X-axis is going to be what? I want to use the fraud column. What? Something is wrong. Something is wrong. This is the column name. X equals to fraud. Let's try and run it. So you can see in my data, if I try and create a visual, so I basically defined that my data frame is df. X-axis, I want the fraud column. So I have 0, which is non-fraud, 1, which is fraud. So you can see how the data looks like in terms of visualization. And I can change the color also, maybe. So color equals to, let's suppose I say yellow. Yellow. So I can just see this yellow color. I can make it pink, maybe. Maybe, maybe not. I can say green color. You get the idea, right? You get the idea. So I'll just put it to blue. This is just, my God, man. These is. So I can see these data distribution so far. So far, I hope that you have followed me so far. So please leave a like and let me know your thoughts in the comment section. Subscribe to my channel for more videos like this. And in the next part of this video, I will show you how do we take this project from this part and start with machine learning model building. Okay, so we'll do the EDA part. We'll see how do we take the approach forward and how do we do the analysis. It might be a little too technical for you right now, but in case you already have some technical knowledge, or if you have some understanding of data analysis, or if you're just curious, for everyone, you can just follow and subscribe my channel. It will really help me if you want to support my channel. So 98% of people who watch my videos are not subscribed, which is a very big number. Because I'm starting out, please do follow and subscribe. Let me know your thoughts in the comment section and I will definitely answer your questions. If you want me to make a video on any specific thing that I've just covered, I would be happy to make so. Let me know what else you need and hopefully you got the value out of it. So I'll see you in the next one. You can also subscribe to my Instagram, which is at the rate AnalyticalAnuj, wherein I post short form content. So it will definitely help you. So I'll see you in the next one. Thank you. It's been 1 hour. Thank you for watching. I'll see you in the next one.